Happy Wednesday, everyone. Sorry I'm not here. I did pre-warn you about this one due to the circumstances and hate that I can't be there with you. Promise I would prefer it. But I want to pick up where I left off yesterday. And for third period, I was not able to do number 15. So I'm going to do 15 and then 17 and 19, which I didn't do in any of the classes. And then I'm going to work through some of these as well. So here we go. I'm going to pick up right here on number 15. So remember what I said. Our first thing that we want to think about is on each side, is there something that I can do? Is there something that I can simplify? And on number 15 here, there's no need because there's only one base of an exponent on both sides. So then we look at those bases and like I've got an 8 and I've got a 32. Now remember what we said. Most of the time we try to take the small one or the big one down to the small one. So I start thinking, hey, can I make 32 have a base of 8? Well, let's think about it. If I went to 8 and I tried to multiply it by itself, 8 times 8 is 64. So I zoomed right by 32. So I can't make 32 down to 8. So it's kind of like the one I did, number 13. I've got to make 8 and 32 both the same base. Well, a lot of y'all look at this number and you think probably 4. Well, let's see if 4 works. You see, if I did 4 times 4, and let me get a pencil here. If I did 4 times 4, 4 squared, that's 16. Well, again, I zoomed right by 8, so it can't be 4. I can't make both of them have a base of 4. So then, naturally, where do we go from there? Well, we go to 2. We want to make both of these have a base of 2. So let's see if we can make that happen. 2 times 2 is 4. Times 2, well, that's 8. So that's 2 cubed. So I can make 8 have a base of 2 by doing 2 cubed. Now don't forget, there was already an exponent of 2a minus 1 up there. You can't just let it vanish. It's got to be a part of the solution. So let's include it. And then let's just keep on going to see if we can get to 32. Well, we already said 2 times 2 times 2 is 8. So times 2, that's 16. Times 2, that's 32. So it took me doing 2 to the 5th power to get 32. Don't forget I had the 2a plus 1 already up there, so it needs to be included. So there it is, okay? That's how we created these bases to be the same. We used a base of 2. Now, from here, like we said yesterday, we're going to drop the bases because they're the same. And then we're going to set what's left over equal. Now, in doing that, I've got to use distributive property. So 3 times 2a is 6a. And 3 times negative 1 is negative 3. So on the left side, I'm left with 6a minus 3. On the right side, 5 times 2a is 10a. And 5 times positive 1 is positive 5. Now, I've got a variable here, 6a. I got a variable here. I always like to move the small one. So I'm going to subtract 6a from the 10a. These will cancel. So negative 3 will equal 4a plus 5. So now in order to get this a right here alone, I'm going to subtract 5. Well, negative 3 minus 5 is negative 8. And that equals 4a. Then I'm going to divide by 4. So negative 8 divided by 4 equals negative 2. So a equals negative 2. Okay, so that was number 15. Again, I did that with a couple of your classes, so thank you for bearing with me. Let's keep on moving along. Number 17, we didn't get a chance to get to this one. It's a little more complex, so let's double check on some things. 1, if you notice the right side, see how you have a 4 and a 4 being multiplied? That means we need to combine these, okay? Now, in that same line of thinking, I'm going to try to get 64 down to a base of 4 as well. If I can, that's what we'll roll with. If not, we won't. So let's do this. Let's go 4 times 4, that's 16, times 4, that's 64. So sure enough, we can get 64 down to base 4, 4 cubed. 4 cubed. Now over here, I think it's important that we all remember what we talked about yesterday. When I'm multiplying and my bases are the same, we can combine those by adding your exponent. Now, here's what I'm saying we need to remember. When I add these exponents, some people look at this and say, well, there's nothing there to add. Well, of course there is. If you have a 4 here, it can't just be 4 with no exponent. It's understood to have an exponent of 1. So when I combine these by adding the exponents, it will actually be 1 plus 4x. Now think about this. Am I allowed to combine 1 plus 4x? Of course not. 1 doesn't have a variable, 4 does. You can't mix them. Now, what can we do? Well, we can mark off our bases. We can drop the bases. So therefore, 3 equals 1 plus 4x. Okay? Now, getting x alone, because there's not x on both sides, so just this one, I'm going to subtract 1. Well, 3 minus 1 is 2, and that equals 4x. And then again, we're trying to get x alone, so we're going to break that 4 away by dividing. Well, 2 divided by 4 is 0.5, or 1/2. Your call what you put, but that is the answer to number 17. Okay? All right, number 19 kind of combines several things, so hang on with me on this one. First of all, I hope that you recognize that there are 2 things on this right side, but they're not the same base. But with 49 and 7, hopefully you guys see that you can get those to the same base, and that base is 7. Now, let's look over here to the left side. It's only one thing here, but can I get 1 over 7 to a base of 7? Absolutely. I can change this to 7, but remember what put it in the denominator? We talked about that yesterday when we did our second example, maybe it was the third example. To make that go to the denominator, I have to use a negative exponent. So since it's the same value of 7, it's 7 to the negative 1. Now over here, how do I make 49 have a base of 7? Well, think about this. 7 times 7 is 49. So that's 7 squared. Now don't forget there was an x plus 5, or x minus 5, I'm sorry, over here already. And that's being multiplied by 7 to the x minus 9. Now, before I combine those, actually, we can go ahead and do this all in one step. Let's leave the 7 to the negative 1 alone for a minute. Remember, in order for me to get this base of 7 and this base of 7 together, because I'm multiplying, I got to add these exponents. So here's what I really have, y'all. I have one base of 7 over here, but I've got this, so 2 times x minus 5, which is 2x minus 10. I use distributive property, plus x minus 9. Now, you could go ahead and simplify this, but I'm going to do that in just a second. What I'm going to do now is I'm going to recognize that I am down to only one base of 7 on both sides. So if those have the same base, again, the whole purpose of us doing this is so we can drop the base. So here's what I'm left with. Here's what I'll solve. Negative 1 equals, now let's get these like terms together. What is 2x plus 1x? 3x. And what is negative 10 minus 9? That's negative 19. So after doing all this work and getting our bases the same, so I could combine them by adding my exponents and then dropping those bases off and setting what was remaining equal to each other, I can now solve this by adding 19. Well, negative 1 plus 19, or 19 minus 1 is 18, and that equals 3x. And then I divide by 3, so x equals 6. So after all that work, I find that the value of x is 6. Okay? All right, so that puts us through with all of the notes from this particular section. So now I want to go back and I want to work through some of your homework that you were supposed to do together, okay? Now, I don't want to do this the whole class period. So I'm going to try to go through this relatively quickly. Remember what I told you. Today, after this is over, Miss Bowles is going to give you guys a study guide for a review or for a quiz. Tomorrow, you'll watch a video over that study guide, and then on Friday when we're back together, we will take that quiz. If you have questions over any of these problems I'm about to do, then please mark them, hold on to them, and be prepared to ask me on Friday before we take that quiz, okay? So here we go. Let's start with number 2. This was your homework from last night. We're just going to quickly move through these problems, and I'll probably not talk quite as much as if I were teaching it, and we'll just kind of knock through this pretty quickly. Okay, number 2. Notice this one's simple. Already have one base on each side. They are the same. Drop in the base. So 4n plus 5 equals n minus 7. I'm going to move the smaller one, so I'm going to subtract that in. 4n minus 1n is 3n plus 5 equals, these cancel, negative 7 drops. So now I get to solve this problem. I subtract 5. So negative 7 minus 5 is negative 12. And then I divide by 3, so n equals negative 4. Okay? There's number 2. Let's keep on cruising. If you need me to slow down or stop, just raise your hand, ask Miss Bowles, and I'm sure she can pause it for you. Let's keep on moving, though, if you don't have questions. All right, number 4. Again, I know this looks crazy, but there is one good thing. Notice on this left side, both these bases are 10. On this right side, both these bases are 10. So I don't have to worry about changing anything. I'm going to keep them a base 10. But what's the rule on getting these exponents together? We add them. So here I'm going to go negative 4 plus 9. Negative 4 plus 9, or 9 minus 4, is 10 to the 5th power. Now over here on the right side again, I'm multiplying. Bases are the same. It'll stay the same, but we're adding these. So that means I'm doing v plus 4 plus 2v minus 11, right? I'm taking this and I'm adding this, just like I did here. I'm just dealing with variables and not just numbers. So I can now drop my bases, and 5 equals, now let's kill 2 birds with 1 stone. What is 1v plus 2v? Well, that's 3v. And what is positive 4 minus 11? Well, positive 4 minus 11 is minus 7. So once those bases cancel and we take what's left over, I have 5 equals 3v minus 7. I'm going to add 7. So 5 plus 7 is 12 equals 3v. I'm going to divide by 3. So v equals 4. And that's my answer. Okay? Again, pause if you need to, but let's keep on cruising. All right, number 6. I don't have any simplifying to do, thankfully, but my bases are not the same. 1's a 2 and 1 is an 8. So I need to create these bases to be the same. So I look at the big one. Can I make 8 have a base of 2? Well, 2 times 2 is 4. Times 2, that's 8. There it is. So I'm going to leave this side alone. It's fine. But this side, I'm going to change it to 2 cubed. You see, I created them to have the same base, so that base can cancel. So therefore, p minus 7 equals 3. I'm going to add 7, so 3 plus 7 equals 10. So p equals 10. Pretty easy one once we had that one set up. Let's keep on cruising. Same thing on number 8. Hopefully you don't find this one to be any more challenging than that one. Look, I got a base 32. I got a base of 2. Well, think about this, guys. There's nothing I can do to get that 2 changed. So I'm hoping I can get 32 to have the same base as that 2. So let's see. What's 2 times 2? 4 times 2, 8 times 2, 16 times 2, 32. There it is. So I absolutely can make 32 have a base of 2. That's 2 to the 5th power. See? Count them. 1, 2, 3, 4, 5 of them. So 2 to the 5th power equals 2 to the 2m minus 9. My bases are the same, so we can drop off the bases. And 5 will equal 2m minus 9. Now I'm solving. It's very simple. Add 9. 5 plus 9 is 14, and that equals 2m. Then I'm going to divide by 2. That equals 7, so m equals 7. All right? Easy stuff. Let's keep on cruising. Number 10. Again, my first goal is, can I make my bases the same? Well, that one's 4 and that one's 16. Let's see if we can make 16 equal 4. Well, what is 4 times 4? Well, there it is, 16. It does it. So I'm going to leave this alone and use 4 to the y plus 2. And then I'm going to change this one to be 4 squared. Now, don't forget, there was already a y minus 3 there. So I'm going to go ahead and multiply those in a second. But first, let's drop off the base. So y plus 2 equals 2 times y, 2y. 2 times negative 3, negative 6. Now, which one's smaller, 1y or 2y? Definitely 1y. So I'm going to subtract y. Cancels. So 2 equals 2y minus 1y is y minus 6. So last step, I'm going to add that 6 over to that 2. So y equals 8 is my answer. All right, to the next page, number 12. Again, I look at my bases. This one's 16. This one is 8. Can I get 16 down to 8? Well, let's see. 8 times 8 is 64. That is not it. Can't do it. I go right past 16, so I cannot make 16 have a base of 8. So what's my next possibility? Well, like I said yesterday, when you can't make one of the base equal the other, you got to bring both bases down. So I know 16 and 8 are both pretty popular numbers that make you possibly think about the number 4. So what is 4 times 4? Well, that equals 16. Now that works for here, but I just went by here. I can't get 4 to 8. Okay, I can't change 8 to have a base of 4. So if I can't change 8 to have a base of 4 like I can the 16, then I got to go further. So we go down to 2. 2 times 2 is 4. Times 2, that's 8. That's 8. So I'm going to change 8 to 2 cubed. Now don't forget, you already had the x plus 2 there. So don't forget it. Now that's not 16 yet, so let's see what else I need to do. So remember what we said, 2 times 2 is 4 times 2 is 8 times 2 is 16. There is the way we get 16 down to base 2. 2 to the 4th. Now again, don't forget 3x was already there, so we've got to take the old and multiply it by the new. But before we do that, drop the bases. So here's our work. 4 times 3x is 12x. Over here, 3 times x, 3x. 3 times positive 2, positive 6. Again, I'm going to bring my variables together. I'm going to move my small one, that's the positive 3x, so I'm going to subtract 3x. So 9x equals 6. I'm going to divide by 9. So x equals either 2/3, or you could put 0.6 repeating if you wanted. Okay, I don't care which of those two you do, but pick one, okay? 2/3 or 0.6 repeating. All right, let's keep on moving along. We go to number 14. Again, I'm trying to get rid of my bases. Well, here's what I've got. I've got an 81 on the left side. I've got a 1/3 on the right. So again, I'm in a little bit of a pickle because I've got to change both of these. So I try to find a root number. Well, since 81 is a bigger number than 3, my first thought is, can I make 81 have a base of 3? So I try it. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. There it is. To change 81 to have a base of 3, I'm going to use 3 to the 4th power. Now don't forget, there's already a 2x plus 5 there, so you got to combine the old with the new. And we'll do that in a second. But let's go over here to this side. How do I change 1/3 to have a base of 3? Well, as you notice, it's the same number, but it's moved to the denominator. What did we say will move that to the denominator? A negative exponent. So we got -1, and that has to be multiplied by 2x. You got to multiply the new with the old, okay? Just like we do here. Don't think you're going, well, -1 plus 2x. No. When you change this to 3 to the negative first power, that exponent has to distribute to 2x. So we get to drop our bases and then solve. Well, how do I do that? 4 times 2x is 8x. 4 times 5 is 20. Over here on the right side, -1 times 2x is -2x. Now, again, we kind of had one like this yesterday where I know this is my smallest term. And I always like moving my smallest variable term, and that's here. So I'm going to add this 2x to move it. Now, some people don't like doing that because it loads up one side. So I got 10x plus 20 equals nothing, 0. That's not a big deal because, again, when I go through the process of solving now, I'm going to subtract 20. So 10x will equal -20. And then I'm going to divide by 10, so x equals -2. Whoop, -2. And there it is. X equals -2. So that one was maybe a little more challenging. Hopefully you guys understood that and did well when you guys worked that problem out. All of y'all had that problem for homework. Now we get into a couple that second period you guys weren't assigned this one because we didn't get to number 15. No, I said that wrong. Third period. Second and fourth, you guys were supposed to do this one. Whether you did or not, I don't know. And I'm not there to check, so you are in luck today. But let's check it, okay? Base of 27. So I'm going to try that, okay? 243 is much bigger than 27. So let's try to bring 27 down as the base. So I try 27 times 27. Now, I doubt you can do that in your head. But if you type 27 times 27 in your calculator, you get 729. That is not it. We just went right by 243. So maybe if you're not as familiar with these numbers, maybe this will be a little tricky. But we're trying to figure out what number could we have as a base with exponents to get me to those two numbers. So maybe you're not as familiar, but let's start working through some, like 2. Well, I know 2 won't give me 27. So what about 3? Would 3 possibly give me 27? Well, let's try it. What's 3 times 3? 9. 9 times 3? 27. There it is. So for 27, 3 will work. Let's check 243 before we get too far in front of us. Again, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. We did that earlier. How about 81 times 3? There it is, 243. So sure enough, 3 is the one that we can use as the base of both 27 and 243. So first, let's do 27. That's 3 cubed. Now don't forget, there was a 2x already up there. We'll distribute that in just a minute. But on the right side, remember we changed 243 to 3, 1, 2, 3, 4, 5, to the 5th. And don't forget, there was an x minus 2 already there. So we did that for what purpose? So we could cross or drop, we say drop our bases. Now, what does that leave me with? Well, 3 times 2x is 6x. And that equals 5 times x, 5x. 5 times negative 2, negative 10. I always move my smaller variable. In this case, it's not the 6x, it's the 5x. So I subtract 5x, and 6x minus 5x is x. These cancel, so x equals negative 10. All right? Okay, number 18, a little bit more challenging, but I want you guys to notice something. Can I, on this left side, can I combine these bases? Well, sure, they're both 9. So I can definitely roll with that, but remember how I combine them? By adding. We add our exponents. So we do 2x plus 4 plus 2x. Now, I'll come clean that up in a minute. Here's my next question. Can I make 1 over 81 have the same base of 9? Well, let's see. 9 times 9, sure enough, equals 81. Now listen, isn't that 9 squared? Yes, but that's 81. What causes it to be 1 over 81? Hopefully you guys recall, that's where the negative exponent comes into play. That's what allows 9 times 9, which is 9 squared, to become 1 over 81 because we do 9 to the negative second power. Now, we can now drop off our bases because they're the same, and we can solve. Well, what does that leave me with on the left side? Well, don't forget, you've got a couple of like terms. 2x plus 2x is 4x. So we have 4x plus 4 equals negative 2. Now, to solve this one, I'm going to subtract 4. Negative 2 minus 4 is negative 6. And then I'm going to divide by 4, so that equals negative 1.5. Or negative 3 over 2, if you'd rather use a decimal, or a fraction. So, negative 1.5 or negative 3 over 2. All right, last one. And again, maybe it's the hardest one. Probably is the hardest one. We are trying to get all of this done. Now, I hope you guys recognize that it looks like to me, and hopefully you see this too, we got a 4 there. We got a 4 on the other side. Can I get this 16 to a base of 4? Well, let's try. Okay, let's try. 4 times 4 equals 16. So sure enough, we can get all of these to base 4. But don't forget, 4 times 4, 4 squared gives me 16. But what gives me 1 over 16? That is 4 to the negative second power. Now, on the right side, we already got 4 to the 6x plus 18. So, that right side, it's good. It's done. This side, because we're multiplying and the bases are the same, we can combine those by adding our exponents. Well, 2x plus negative 2, remember, you're not multiplying. Because the bases are the same and we're multiplying, we add. So 2x plus negative 2 is 2x minus 2. Now on the right side, of course, we already have this one simplified. We're going to go ahead and drop our bases and solve. So 2x minus 2 equals 6x plus 18. I'm going to move my smaller variable part, that's minus 2x. I'm going to get negative 2 equals 6x minus 2x is 4x plus 18. I'm going to subtract 18, so negative 2 minus 18 is negative 20. And then I'm going to divide by 4, so negative 20 divided by 4 is negative 5. So x equals negative 5. And that's it. That is how you solve exponential equations by dropping the base. Now, this video is about 30 minutes, so you should have about I don't know, somewhere in between 10 to 15 minutes to start looking over your review. The expectation is that hopefully you've looked at it, done some of it when you come to class tomorrow, so you're not completely lost as we go through the review together. But there will be a video tomorrow again. Again, I apologize. I'd rather be here in person. But that video will be going through the review that you are getting right now. Again, I hope you have a great Wednesday. I'll have another video for you tomorrow, and then I'll see you for a quiz on Friday.